fx, right? Quadratic equation lesson. Fx given as x squared plus px plus q, and also given q minus p plus 1 not equal to 0. Asking to show that -1 is not the root of fx equals 0. Right, fx equals 0 mean fx is this, no? X squared plus px plus q equals 0. Now we have to show -1 is not the root of fx equals 0. Then we use the contradictory proof. You know what is meant by contradictory proof. Under contradictory proof, what we need to assume is the one we need to prove exactly opposite of that we assume as true. Then here we need to prove -1 is not the root, right? So then we assume -1 is a root. Then we think it like this. Let -1 be a root of fx equals 0. If this -1 is a root of this is the fx equals 0, no? Then this -1 should satisfy this equation. Then you can write -1 squared p into -1 plus q equals 0. Right? Let -1 be a root of fx equals 0. Then we can write then f -1 should be 0, no? F -1 means substituting for this x is -1, no? Then this is what we get here. This is 1 minus p plus q equals 0. This is nothing but q minus p plus 1, the same thing, no? Q minus p plus 1 equals 0. We get this way, right? But this is the one here we are given not equal to 0. Okay, but this is impossible. This is impossible. Why? Given that q minus p plus 1 not equal to 0. Therefore, this is impossible means -1 be a root of fx equals 0 is impossible. Right? Then you can write, therefore, -1 is not a root of what? Fx equals 0. Right. Here the marks you get this one, x minus 1 equals 0 for this 5 marks coming. And substituting that -1 here, another 5 marks. Taken this 10 marks. And finally, writing -1 is not the root of fx equals 0, another 10 marks coming. This is how the marks come. Huh? Okay, next one. Let the roots of fx equals 0 are alpha beta. Roots of fx equals 0 given as alpha beta. Okay. Yeah. X squared plus px plus q equals 0. It would only given as alpha beta, right? Then you can write sum of the roots and product of the roots. Sum of the roots is minus p, product of the roots is q. Right, now asking, show that alpha plus 1, beta plus 1 is this, and 1 upon alpha plus 1, 1 upon beta plus 1 this. Then we can write alpha plus 1 times beta plus 1. Triple bracket alpha beta here, right? And alpha plus beta and 1. This way we can write that. Huh? Then you can substitute for alpha beta is q, alpha plus beta minus p plus 1. This is the alpha plus 1, beta plus 1. Okay. Then next one, 1 over alpha plus 1 plus 1 over beta plus 1. To get this, we will take the common denominator here, the product of these two, alpha plus 1, beta plus 1 product, this product, then this comes here, then we get beta plus 1, alpha plus 1, right? Then here, we can write this as alpha plus beta plus 2 divided by alpha plus 1, beta plus 1. This here. Then you can substitute for this alpha plus beta, p minus p. Then this is 2 minus p. And this alpha plus 1, beta plus 1 product is, right? Is no 2 minus p plus 1. This way we get that, no? Then here when I write the marks, people put the marks also, because the important steps you have to understand to which you get marks. Right. So then for this 5 marks given, this 5 marks given, and expansion of this are the 5 marks, and this answer given 10 marks, and this one for the step this 5 marks, simplifying and getting this one 10 marks given. This is how the marks coming. Right, next one. Then show that the quadratic equation 1 upon alpha plus 1 and 1 upon beta plus 1 as its roots is this. Right. Quadratic equation with the roots. Right. Quadratic equation with the roots 1 over L plus 1 and 1 over B plus 1 is, you know, when we are given the two roots, the way of writing the quadratic equation. What is that, people? X squared minus within first bracket sum of the roots. This here times x. Secondly, product of the roots. Equals 0. The sum of the roots here we have, and this one we can write here. And then we get x squared minus, for this sum I can write 2 minus p divided by q minus p plus 1 x. If this product L plus 1 b plus 1 product is this 2 minus p plus 1 equals 0. Then we can multiply this q minus p plus 1. Then this q minus p plus 1 x squared. This will cancel with this multiplier. 2 minus p times x plus 1 equals 0. This way we get that answer, right? Then for the step this we get 5 marks, right? Substituting, getting this one 5 marks, and multiplying, getting this finally 10 marks, right? Right. Next part is this. Let the minimum value of fx be L1. Minimum value of fx be L1. Show that L1 is minus delta by 4, where delta is p squared minus 4q, the discriminant. Huh? Yeah. Yeah. Fx given as x squared plus px plus q. You know, to find this minimum, we have to complete the square of the right hand side. Now, how to complete the square? Put perfect square. You know, before completing the square, x squared coefficient should be plus 1. Now, that is okay here. Then from this x square, we take only x plus this x coefficient we have to divide by 2, p by 2. Then what? The third term we write as it is, and we always subtract the perfect square of the second number. It is p squared by 4. Okay. Then you know, people, in quadratic equation lesson we said the coordinates of the turning point, vertex, x and y coordinates, we can obtain how? Taking the sign minus opposite, this gives x coordinate. After the bracket, the resting gives y coordinate. Then you know this graph is x squared coefficient positive, no? It is a minimum graph. The graph is like this. The minimum value means this lowest height. This lowest height is the y coordinate of the what? Vertex. That's only given by this. Therefore, you can write L1 is this q minus p squared by 4. We can simplify this. L1 4q minus p squared by 4. L1 take minus sign out. P squared minus 4q divided by 4. But we are given this question delta p squared minus 4q. But delta p squared minus 4q, no? Okay. Then this is that delta. Therefore, we can write L1 is minus p squared minus 4q is delta divided by 4. This is the minimum value. Okay. And now here marks we get for the step this 5 marks come in, and simplifying this way, finally getting this one 10 marks coming. Right now. Right. Okay. Now next part is this. We are given another quadratic function called as hx. Hx. Hx is x squared plus p minus 2 divided by q minus p plus 1 times x plus 1 upon q minus p plus 1. This is a quadratic function. Right. Here also we had quadratic function. If the minimum value of hx is L2, show that L2 is this answer. There, think like this. The fx function its minimum value we found. It is this L1. When you consider this expression, it is the L1 minimum value of this, no? See the way of getting this? Minus sign we have, within bracket we have P square. It means the X coefficient square, right? Minus 4Q. Minus 4Q means this constant. Divided by 4. Then compare this and this. This is the X coefficient as here P. Right. This is the constant term as a Q. Then if the minimum of this is given by this expression, similarly for this one, its minimum should also be given by the same thing minus for this P and Q now, we have substitute this and this. I think you can understand this logic. Understood. Then we can directly write without writing this way. For that, unnecessary work, people. By just comparing this two, you can take this answer. They expect like that. Though you this way complete the square of that, the same answer come in, but no extra mark. Because as a L student, if for this one you can take the L1 in this manner, you must have the idea. Similar thing is there. Only thing is P and Q, this and this respectively. Therefore, substituting those things there, we should be able to take the minimum of this. Then I follow like that, right? You can write by the above this R. The minimum value of this Hx given as people L2, no? Then I can write L2. I can write L2. L2 will be minus within bracket. P squared means square of this. P minus 2, Q minus P plus 1. Perfect square. Minus 4 into Q. Q is this. 1 over Q minus P plus 1. It should be divided by 4, no? This 4. Shall I write that 4 as multiplication of 1 upon 4? Correct, no? Dividing by 4 means multiplying by 1 upon 4. Okay, no? Now we have to simplify this, huh? Right. I'll simplify this now, people. L2 minus Q1 over 4. Here, Q minus P plus 1 perfect square, no? That I am going to take as common denominator. So this is Q minus 2 perfect square minus 4 times. Since this is a perfect common denominator, this should be multiplied by Q minus P plus 1, no? Then you have to simplify that. L2 minus P squared minus 4P plus 4. Remove the bracket. Minus 4Q plus 4P minus 4. Let's see. This minus 4P plus 4P you can cancel down. 4 and minus 4 you can cancel down, no? Then we get L2 minus P squared minus 4Q divided by what? Q minus P plus 1 perfect square, huh? Like this. Correct, no? Then you know this is delta. Right, now you can use the cross multiplication by this. It's therefore q minus p plus 1 per x squared into L2 equals minus p squared minus 4q is this delta, no? Minus delta, we get there because we use the cross multiplication, no? It's minus delta. But people, what is the answer asking to show there? Q minus p plus 1 perfect squared into L2 equals L1. Another mistake I did here, this 4 I didn't write, no? That 4 should also be coming here. Right. Then here we have minus delta by 4. But you know, minus delta by 4 is L1. Therefore, this is L1. No? Here we get like this. Okay. Correct, no? Yeah. That also coming then. Okay. Then people, here the marks coming like this. For this step given 10 marks. Right, getting L2. Yeah, this one. Another 10 marks. And taking this answer 5 marks. Okay, no? Yeah. Now another proof is there. Hence prove that for all real values of x, fx greater than equal 0, if and only if hx greater than or equal 0 for all real values of x. Yes. That one we can very easily prove like this. There you have to very carefully understand what is this question here to prove. Yeah. Hx greater than or equal 0 for all real values of x. You know, this hx function, people, x squared coefficient is plus 1. This hx represents minimum graph. Then its hx mean the y minimum graph, it should be like this. Then only when we move from negative infinity towards positive infinity, at every value of x, this height become positive. Become positive, right? That means this occurs. Equal 0 means this point should come to here. Then this is the one greater than 0 here, here equals 0, this side greater than 0. Therefore, satisfying this greater than or equal to 0, this should be the graph of hx. Then you can see if all y values are positive, you can see this minimum point y value that we took as L2, no? L2 positive. In this case, L2 equals 0, the minimum value of hx, right? That means in order to occur this, what can you say is, people, L2, the minimum value of hx, should be greater than or equal to 0 for all real values of x. Okay. Right now. But L2, we can subject by this. What is that? L1 upon this. Q minus p plus 1 perfect square. What? Greater than or equal to 0 for all real values of x. You know, people, this is perfect square positive. We proved this is not equal to 0. No? At the very beginning of this question, we are given q minus p plus 1 not equal to 0. So therefore, when this is not equal to 0, it's perfect square, right? It's always positive. This fraction should be positive or equal to 0. Since this is positive, for this fraction to be positive or equal to 0, this L1 should be greater than or equal to 0. What? For all real values of x. Okay. Then this implies this, this implies this, this implies this. Because L1 greater than or equal to 0 means what? What is L1? L1 means the minimum value of fx function. Then, if I depict this on the diagram to explain this L1 greater than or equal to 0 for all real values of x mean people, the fx graph also a minimum graph because its x squared quotient is positive. Then the fx graph, if it is like this is L1. The minimum value is positive. Then the graph should be completely like this above the x-axis. L1 equals 0 mean people, it should be like this. In this case and this case, you can see, in this case, this whole height positive. That means fx positive. In this case, at this point, y coordinate is 0, no? Fx 0. In the other points, fx positive. Then this L1 greater than or equal to 0 means this says what? Fx, the y value of the fx function, y coordinate, the height, in other words, greater than or equal to 0 for all x in R. Then we proved the if part. What is this part? If hx greater than or equal to 0 for all real values of x, then that implies fx greater than or equal to 0 for all real values of x. Understand? Then only part we can prove taking backward direction like this. This is how we do that question, right? Okay. Second question, the limit part. The limit part also we have done, no? Right? The marks here, 5 marks, for this 5 marks, for this 5 marks. Backward proof means really we put the backward arrow, only proof. For that, you get another 5 marks. That's how the marks come in, no? Right. Then we come to the limits part. Right. That is limit x going to second question, huh? Part 1. Limit x approaches to 1 upon root 2. X minus cos sin inverse 6 divided by 1 minus tan sin inverse 6. The answer of this we have to prove minus 1 over root 2. Right. You know, people hear this sine inverse x mean this is an angle. Correct, no? You know, when I write sine 30, it is half, no? If I subject this angle, that can be done taking the sine to right hand side and writing it as sine inverse half. That's why I said sine inverse something means the result is an angle. So therefore, the sine inverse x also an angle. Then I am going to take that one like this. Let theta equals sine inverse x. Theta equals sine inverse x. Okay. That means taking the sine inverse to this side, we get sine theta equals x. Sine theta equals x. Okay. Then here the limits x going to 1 over root 2, no. Then you can think like this as limit x going to 1 over root 2. Suppose when I put 1 over root 2 here, then what do you get there? Sine theta equals 1 over root 2. Then for what angle? Sine becomes 1 over root 2. 45. 5 by 4. This is theta 5 by 4, no? That's a limit x going to 1 over root 2 means what? Limit theta going to 5 by 4. Okay. Now, I can write this given question this by introducing this angle theta this way. Right. Now, remember, at the beginning, when we do this way questions, people, you sometimes find little inconvenience of understanding these. Right? That is usual thing until you do 5-6 papers. Until then, right, try to understand and first write down these answers and again do the paper until you understand some techniques of getting the answers, right? You find this little inconvenience, right? Okay, we'll come to the next part of this. The question is that, no, limit x going to 1 over root 2 x cos inverse, sorry, not cos inverse, cos sine inverse x divided by 1 minus tan sine inverse x, no? Right. Here we notice as x going to 1 over root 2 means theta going to 5 by 4, no? So therefore, this one we replace by theta going to 5 by 4. Okay, right. Now what is this x? X is now sine theta. Put that sine theta there. Minus cos sine inverse x. Sine inverse x is theta. Right. 1 minus tan sine inverse x. It is theta, tan theta. Okay, right. Now we can write the next part like this. Right. Sine theta minus cos theta. This tan theta I can write as sine theta by cos theta and here 1. Now I simplify it like this. We take this cos theta as the common denominator for this denominator. Then this 1 will be cos theta and this cos theta goes to numerator. No? Like that. Okay. Then we will have like this cos theta times sine theta minus cos theta divided by this is now cos theta, no? Cos theta minus sine theta. Okay. Then you can cancel down this and this. Here we get -1. No? The reason? This is sin theta minus cos theta. This is cos theta minus sin theta. You can take minus sign out. Then only denominator, this term will be forming. Then only we can cancel down. That outside minus sign will finally give minus here. This minus sign you can take out from this. Okay. Now put 5/4 we are here. Okay, minus cos 5/4. Cos 5/4 you know. 1 over root 2, then minus 1 over root 2 coming like it. This is how we take this answer. Then here for the substitution, 5 marks come in. Conversion of this limit, another 5 marks. And people write in this one another 5 marks. And getting this cos theta for another 5 marks. And final answer, another 5 marks. This is how we get the mark. Okay. Right. Its second part. Given y. Y equals sin inverse. 3x plus 4 times square root of 1 minus x squared divided by 5. Asking to prove this differential equation. Now, if somebody tried this way itself, the simplification is too long. I noticed yesterday some students tried to take this answer, but I am sure nobody could get this answer. Very long, but we can take this very easily this way. People, you know, here this 1 minus x squared. Okay. This 1 minus x squared part should be positive. This one should be positive. If this is negative, it's like square root of minus 3. This is imaginary. Then this question is really not very. Right. This question, to express this question, this should be 1 minus x squared should be positive. So that this x squared should be less than 1. X squared less than 1 means x should lie between +1 and -1. Then only this x squared will be less than 1. Given 1 minus x squared positive, root of positive value we can find, then the question is okay. But you know, people, when we consider in trigonometry the sine graph, the sine theta graph, can you remember? Sine theta graph, you know, fluctuate between +1 and -1. For different angles, the sine theta graph, right, fluctuates like this. Then you can very clearly see, if you have any real number between +1 and -1, that real number, whichever it is, you can write that real number. For instance, if I take here 0.21, then I can find for that an angle from the angle axis here. Now, if we take this angle as alpha, its sine value is this 0.21. Like that, whatever the real number lying between -1 and +1, that real number you can write sine angle. such angle you can find here. This is minus 90, this is plus 90. Such angle available between minus 90 and plus 90. Understood? So therefore, here also this x, since it lies between minus 1 and plus 1, I can write that x as sine theta. There is such angle theta between minus 90 and plus 90. Using x equals sine theta substitution, if you try this one, very easily you can take the answer. That is not going that much long. Right. So then we use the substitution that. Okay. What substitution? You can write since x is than or equal to plus 1, greater than or equal to minus 1, right? Let x equals sine theta. This x, the same x, we can write as sine theta. Then I can write this one. Then y equals sine inverse 3 sine theta plus 4, 1 minus sine square theta divided by 5. This is 1 minus sine square theta cos square theta. Its root is cos theta. Then I can write y equals sine inverse sine theta. Here 3, that should be divided by 5, 3 by 5. This is paper cos theta. 1 minus sine square theta root is cos theta. 4 by 5. Like this we have. Okay. Then when you take people this 3 by 5, this part, this is a value less than 1, no? 3 by 5 means 0.6. That 0.6 we can write as cos angle. You can remember the cos graph, no? The cos graph also people fluctuating between plus 1 and minus 1. Okay? Because until you learn these techniques, you can't work out the question smoothly. Right? From at the beginning of the paper, when you work out questions, if you don't know this kind of techniques, you can't take the answers easily. So therefore, first 4-5 question papers, you can't so much. Don't worry, right? Yeah. Now, the cos theta graph, when we come to the people, this is the cos theta axis, this is the theta axis, here 1, here minus 1, then the graph is like this here. Then when I consider this 3 by 5, it is 0.6, no? 0.6 is somewhere here. For the 0.6, there is an angle, no, here. Then if we take this angle as beta, its cos value is, cos beta is 0.6, that is nothing but 3 by 5. Therefore, we can take this 3 by 5 as cos beta. If you take this 3 by 5 as cos beta, automatically this 4 upon 5 will be sine beta. How? You can prove it like this. Then you are sure that 3 by 5 we can write as cos angle. I will take that angle as alpha. Let cos alpha is 3 by 5. Then for this cos alpha, if you draw a right angle triangle like this, this is alpha, adjacent side is 3, hypotenuse is 5. Then this opposite side you can take how people, hypotenuse of x square 25 minus 3 square 9, 25 minus 9 is 16. Its root is the opposite side this. See here now, when I write sine alpha, will be what people? Opposite by the hypotenuse, 4 by 5. Alright, as I told you, now when I take it 3 by 5 as cos alpha, 4 by 5 as sine alpha. Then I can write that one, y equals sine inverse, what? Sine theta cos alpha plus cos theta sine alpha. This way you can write. Then this is nothing but what? Sin A cos B plus cos A sin B. It is sin A plus B. Y equals sin inverse sin theta plus alpha. You know, people, sin inverse sin means what? Sin inverse sin means this angle. For instance, you know this, no? Sin 60 is equal to sin 60, no? This is an obvious result, no? Then, if I need to subject this angle pi by 3, we have to take the sin right hand side as sin inverse. Then pi by 3 is equal to what? Sin inverse sin pi by 3. See here, sin inverse, right? This angle on the left hand side comes. Like that, sin this angle inverse before we have. Then sin inverse sin means this is the angle. We get y equals theta plus alpha. Alpha is a constant now. Why? Alpha is a fixed angle whose cos value is 3 by 5, sin value is 4 by 5. So that is alpha is a constant, right? Now, let's see the marks coming here. This 5 marks. Okay. Put in here 5 marks and get in this another 5 marks. Okay. And get in this 5 marks. Finally, we get this. Then we have what? Y equals theta plus alpha. What is x? X is sin theta. X is sin theta. X is sin theta. Now, we need to find people dy by dx first. Dy by here, we can write dy by d theta. We can differentiate this right hand side with respect to theta. Here 1. Root of theta with respect to theta is 1. No? Alpha is a constant. When you differentiate a constant, it's 0. Here we can differentiate this dx by d theta. This we can differentiate by theta. When you differentiate sin theta with respect to theta, we get cos theta. Now, by using chain rule, we can write dy by dx. What is dy by dx? Dy by d theta into d theta by dx by chain rule, no? Then substitute for here, dy by d theta, it is 1. D theta by dx means reciprocal of this, 1 over cos theta. Then we can write dy by dx is equal to dy by d theta is 1. D theta by dx means the reciprocal of this 1 over cos theta. Okay, right. Then we get use the cross multiplication to this end. Cos theta times dy by dx is equal to now 1. Now we can go to the next one. Okay, right. Now for this one, 5 marks coming. 5 marks. Right. This one 5 marks. Now what we do, people? Again, we differentiate this. Once we differentiate again with respect to it, you can write differentiating again with respect to x. Tell me here how to differentiate this. We have to take this as u, this as v. Product formula we have to apply there. Understood? Product formula. What is that? First, we have to keep this cos theta and differentiate this. This is first derivative. No? When we differentiate that again, we get second derivative. Right? We keep this as the same and differentiate this. Plus, we keep this as the same. Differentiate this cos theta with respect to x only. We do this way. Right? Directly we can't differentiate because here we have theta, here we x. No. Right hand side we have a constant which is 0. Derivative of constant is 0. Right. Now let's see how to do the next part. Right. Here we can put the chain rule. Dx place we put d theta, and to cancel down this d theta we write here d theta and this dx. This we can write, no? So this d theta cancel off, d cos theta upon dx, this is coming. Right? We could have done this straight away without explaining this much, but I'll explain like that. Now you can write here what people, dy by dx. When you differentiate cos theta with respect to theta, it is minus sin theta, no? Minus sin theta. D theta upon dx, right? Here dx upon dt to cos theta, then the other way around only there we need, it is 1 over cos theta, right? Equals 0. Here we have cos theta d2y over dx2. Then multiply this throughout by cos theta. Then it is cos square theta, second derivative. Here this cos theta will cancel off, giving minus sin theta dy by dx equals 0. Okay. Now this cos square theta I can write as 1 minus sin square theta. d2 y over dx2 equal this sin theta I write at the moment like that. Okay. But you know people, sin theta was what? Here sin theta is 6. Then for every sin theta you can put 6, right? So what do you get? 1 minus x squared d2 y over dx2 minus x dy by dx equals 0. This is how we take this answer, right? All right. Did you think this much to take the answer? Right. This is how we take people the answer, right? Right. Now the marks come in like this. Right. Here for this 5 marks. Right. And then this one 5 marks. And for the step this 5 marks. Final answer on the 5. Right. Right. Next one is the graph. Application of derivative 1 is the graph sketching, no? Graph sketching. We'll come to that one now. Right now sometimes there can be some other method to get the answer. I think in this part, the easiest way of getting the answer is this. Right? Okay. Next one, given this graph, right? Fx, third part, right? Fx, x squared over x minus 1, x minus 5. Right. By finding horizontal and vertical asymptotes and stationary points, sketch the graph of y plus fx. Okay, right? Not asking to find points of intersection. Then of course don't go to find them. Right. Right. Vertical asymptotes first we have tried. This fx means people read y, yeah? Y equals x squared upon minus 1, x minus 5. Vertical asymptote. How to write vertical asymptote, people? Equate this denominator factors to 0. X minus 1, 0. Or x minus 5, 0. X equals 1. X equals 5. Other vertical asymptote. We did this kind of questions, huh? Right. And the horizontal asymptote, we can find taking limit x going to plus or minus infinity. There, I take this x out from this bracket and x out from the second bracket. Then x squared coming down from the denominator. When you take x out from this bracket and x out from this bracket, both this bracket and this bracket we have to divide by x. Then we get 1 minus 1 over x here, 1 minus 5 over x. Then this and this you can cancel down 1 here. Then put the infinity here. Infinity here. 1 over infinity means this is 0, this bracket 1. 5 over infinity means this is 0, this bracket 1. Then 1 into 1 means 1, 1 over 1. It is 1. Therefore, horizontal asymptote is 1. Understood? Okay? All right. Then, for this 2, 10 marks. For this one, 5 marks. Right. Okay. Next one, to find the stationary point, you have to differentiate this now. You have to differentiate this. Right. Y equals x squared upon x minus 1 into x minus 5. No. Right. Tell me how to differentiate this. This one you have to take as u. This product you have to take as v. Right? U upon v form you have to follow to differentiate this. What is the formula? dy by dx. Right. First we have to square this denominator. Perfect squared. And the same denominator we have tried at the very beginning of the numerator into derivative of this 2x minus, keep this now x squared, and that should be multiplied by the derivative of this denominator. How to differentiate this, people? This is the product. We differentiate this as a product. Keep this first as the same, multiply that by the derivative of this, plus this as the same, multiply that by derivative of this. Right. So what do you get there? X minus 1, we keep as the same. It is multiplied by the derivative of this. Derivative of x is 1, 5 is a constant, 0, therefore 1. Plus, keep x minus 5. Right? Keep x minus 5. And multiply that by the derivative of x minus 1, it is 1. We get something like this. People, now, by simplifying this numerator, we can take the dy by dx. I leave the simplification part to you. Finally, we get dy by dx simplifying this way. 2x with minus sign, 3x minus 5 within bracket, divided by x minus 1 perfect squared, x minus 5 perfect squared. This way we get. Right. So in this case, for the differentiation, you get this step 5 marks, this answer 5 marks. You know, next one is for stationary points. For stationary points, what can we say? Dy by dx equals 0, no? For stationary points, dy by dx equals 0. That means this right hand side must be 0. When the right hand side minus 2x into 3x minus 5 divided by x minus 1 perfect squared x minus 5 perfect square when we equal to 0, this fraction becomes 0 when this numerator 0. This implies minus 2x 3x minus 5 0. That says what? X equals 0 or 3x minus 5 equals 0. That directly gives us x equals 0, and 3x minus 5 equals 0 means what? X equals 5 by 3. There are two station points with x coordinate 0 and 5 by 3. For each of this x value, we have to find y. X equals 0, we have to put where here. Then this will be 0, then y 0. Then one station point has x coordinate 0, y coordinate 0. Therefore, at the origin only, first station point. The other x value 5 by 3, you have to substitute where here, people. Then find y. Then that y, we get like this. Y equals, right, minus 5 by 4. Then the other station point is 5 by 3 minus 5 by 4. I am not going to show you how to simplify putting this x equals 5 by 3 in that y. In the expression here, put in for these x places that x is 5 by 3, simplify that terms you get. Okay, right? So don't expect that kind of simplifications. You should do this question again yourself. That occasion, you have to simplify and check whether you get this answer. Okay, right. If we do every simplification here in the paper discussion, it takes a long time to discuss the paper, right? Okay, now today our actual speed is very low, so that everybody can understand. But with doing papers like this, people, I am not going to explain this much in differentiating this kind of function. Understand? You'll be able to understand that. Right. So then, the thing is, go through all the previous notes and be ready for the next day paper. Next day paper you can very easily do than this paper, right? When we do paper by paper, people, the skill you can improve, provided if you have what a good necessity and motivation. Otherwise, paper discussion and paper class will be boring. Right. Okay. Now search points also be found, right? So therefore, here for this we get 5 marks, and this one 5 marks. Here this 5 marks, right? For this coordinate 0 0, 5 marks not given because put in x equals 0, very easily we can find y. Okay, right. Now you know, right? We need what? A table to draw what? This graph. On this table, we first mark the x values of station points and vertical asymptote. Station points x equals 0 and vertical asymptote x equals 1. Other station point coordinate is 5 by 3. Other vertical asymptote point is 5. There are how many regions? 1, 2, 3, 4, 5. In the table, there are 5 ranges, no? Then prepare the table like this now. Right. What is this range? X less than 0. This range between 0 and 1. Here between 1 and 5 by 3. This is 5 by 3 and 5. This is greater than 5. In each interval, we have to find the sign of dy by dx. Right. This is our dy by dx. Its sign only now we need to find in each interval in the table we have. There you have to remember, people, this denominator having perfect squared, then it is always positive. Therefore, to decide the sign of dy by dx, we have to only consider the sign of this numerator. because this is always positive, right? When you divide certain value by positive, the sign doesn't change. Here, remember, we find only the sign of dy by dx, not its exact value. Understand? We need whether it is plus or minus. That's only we supposed to find. Yeah. When you put people, suppose x less than 0, like x minus 1, here put minus 1, minus 2, minus 1, this is plus. Here put minus 1, minus 3, minus 5, it is minus 3. Then we get dy by dx negative. Right. So then when I take that x value from each interval and put in that, we get the sign of dy by dx in this way. You can do this also yourself when you do this question alone. Okay, right. Now you can say here gradient negative people. In the recent marking scheme, they expected this thing also in the table. Right. Remember like this. You know, gradient negative means if I draw a curve with gradient negative means this, no. Negative gradient curve is this. This is the x-axis, right? This y-axis. When we move to right people in the direction x increasing, you can see what happens here. The y is decreasing, right? Then we say what? Gradient negative means function or the y decreasing, right? Decreasing, y decreasing, or decreasing function simply. A gradient positive line, if curve, if I draw like this, like gradient positive. When we move towards positive infinity of x, you can see this height increasing here. Then gradient positive graph we define as increasing graph. So therefore, the recent past paper marking schemes, they expected that also. Gradient negative means decreasing. We write here decreasing. Here increasing. Here increasing. Here decreasing. Here also decreasing. That also you must write here. Okay. Recent marking scheme, of course, that is available. Yeah. Now we'll see here. Gradient negative means this shape. Gradient positive means this shape. But x equals 0, we notice gradient 0. Therefore, here we have a what? Minimum. Another staging point is at pi by 3, no? Gradient positive this shape, 0 this shape, negative this shape. It is this. It is maximum. Then one minimum and one maximum we have in the graph. Now we have draw the graph. Understand? We have draw the graph. Let's see how draw the graph. Yes. Now right, I give the marks, no? For the table, people 10 marks only coming. Right. Right. Now this way. X equals 1 we have word lesson taught. X equals 5 also we have word lesson taught. Therefore, at x equals 1, draw vertical dotted line like this. At x equals 5 also, vertical dotted line we have to draw like this. Right. Okay. And horizontal asymptote is y equals 1, no? Then that also we draw like this. Horizontal asymptote. E1. Okay. Right. At 0, 0, minimum we have 0, 0 is here. This is negative x, 0, 0 here. Here we have minimum. Right. In the interval 0 to 1, gradient positive, but at 1, vertical asymptote. Between here and here, gradient of the graph should be positive. That means graph should be like this. When we go closer to 1, there is a vertical asymptote. So therefore, this portion of the graph should be like this. Right, no? We have at 5 by 3, x equals 5 by 3, we notice y is minus 5 by 4. Then this is 0, 0. X equals 5 by 3. Somewhere here 1 point something. No, 5 by 3 means 5 by 3. Y is minus 5 by 4. Then this is that point. There's a maximum here. Okay, maximum. Then the shape should be this way. Between 1 and 5 by 3, here, gradient positive. 5 by 3 and 5, gradient negative. That means on the left of this positive gradient, right of this negative gradient. So therefore, it will be like this. Because when we draw this one, the turning points x, y coordinates clearly you have to mention for these marks upward, right? So therefore, this one 5 by 3. If you can write here 5 by 3 and minus 5 by 4, that's okay. Though you write on the axis like this, that's also possible. Okay, not both required there, right? Okay, the next one is, right, this is the last branch I'm going to draw in the graph. You know, the last branch only will achieve horizontal asymptote. Let's see on the right of 5 in the table, gradient negative. Gradient negative graph can be this way or this way. One of that two. Both are gradient negative. Now, on the right of 5, gradient should be negative. And once we go towards the positive infinity of x, the graph should go to value 1. To satisfy that both, graph should be having this shape. See here, the gradient is negative. Gradient is negative. When we go closer to this 5, this height going to infinity because there at x equals 5, there's a vertical asymptote. Now, when we move this direction, you can see this graph is coming closer to this value y1. That is because of the graph has horizontal asymptote. Okay. Now this side. This is a branch which can continue this portion on the left of 0. On the left of 0, gradient negative. And this is the branch that can go towards the negative infinity of x. But you know, as x going to negative infinity, we found our horizontal asymptote as 1. No. That says when the graph is going towards the negative infinity direction, the graph should come closer to this 1. Therefore, this is the portion that should come to 1 line. Okay. This is the graph. This is the graph, right? For the graph people, 10 marks given now. 10 marks. Right. Another part is there. What is that? Hence find the number of solutions of the equation. This. Right. Now, you know, right now I'm erasing this. Okay. Right. This is the equation given us. Hence find. Hence means using this graph. Okay. X squared, right, divided by x minus 1, x minus 5. Right? Minus e to power minus 6 equals 0. Taking this side, you can write the given equation like this. When you take this as y, it is this graph. When you take this as y, it is another graph. That graph will draw y equals e to power minus 6. Then solution of this equation means what? The x values, this graph and this graph are equal. Understand? The solution of this equation means this graph and this graph, they equal no? At that point x value. Equal means what, people? Y values are equal. For y values to be equal, the two graphs must intersect each other. Now, for instance, in a plane, if we draw two graphs like this, at this point of intersection, the y values of these two graphs are equal. That kind of equality here has happened. Then solution of this equation means at the points of intersection only the y values or the graphs are equal. At those points, x values are the solution. So therefore, to find solution of this, what I have to do, I have drawn this graph and this one I have to draw on the same pair of axes. Then the two graphs will intersect at some points. At those points, x values are the coordinates or the solution of the given equation. Let's see how to draw this graph y equals e to power minus 6. Right. Right now. Then I'm going to draw this one. E to power minus 6, I can take like this, e to power plus 6. People, you know what is e? E is approximately 2.71. Right? Actually, we have drawn this y equals e to power minus 6 graph in differentiation. Right? But I'm going to do that again. Right? We take it like this. Number 1. As x going to plus infinity. What happens to this y? 1 over here plus infinity. E is 2.71. That power infinity means this is infinity. 1 over infinity is 0. That means what, people? As we go to the right of x-axis, y 0. Number 2, as limit x going to negative infinity. Put in negative infinity, y 1 over e to power negative infinity. Take this to numerator, e to power infinity. E means 2.71. That to power infinity means this is going to infinity. Number 3, when x equals 0, put x equals 0 here. E to power 0 is 1. 1 over 1 is 1. Y is 1. All right. Then if I sketch this graph, this says what? As x going to infinity, y going to 0. That means when we go this way, right, the graph coming closer to x-axis. And as x going to negative infinity, that means when we go this way, the y going to plus infinity. And x equals 0, y is 1. X equals 0, y equals 1 means x equals 0 here, y1 means here. Our graph passes to the point this. Then using these 3 points into account, when we draw the graph is like this. This is the y equals e to power minus. Now you can see, we said what? The solution of this equation means when this graph and this graph cross each other, at that point x values are the solution. You know, the crossing occurs only at this point. Only one intersection available. Therefore, the equation has only one solution. Understand? Okay, then we can explain that. I write down like this, one sentence. But the solution of the given, the solutions of the given equation are the x coordinates of the points of intersection are the x coordinate of the points of intersection of the above graph and the graph y equals e to the power minus 6. The graph y equals e to the power minus 6. By the diagram, the two graphs intersect only at one point. Therefore, the given equation has only one solution. Right, people, for the graph y equals e to the power x, 5 marks given, and finally the explanation this way, other 5 marks. This is the end of this question. Right. Next one, take question number 3, part A first. Question number 3, part A. Question number 3, part A. Right. Given the fx third degree polynomial function, show that when fx is divided by x minus 1, x plus 1, the remainder is for x minus 1. We can do this in two ways, either by algorithm of division or log division, whichever it is correct. Right. I am going to take algorithm of division. It is this. The function is x cube minus 2x squared plus 3x plus 1. It is divided by x minus 1 and x plus 1. No? Then this is the divisor. I am going to assume the dividend as 5x and, right? This is the divisor, right? This is the quotient, no? The dividend is this, divisor is this, quotient, and the remainder I am going to assume as ax plus b. Right? Then put x equals 1. Then what happens? This is 0. Then this entire product is 0. Here a plus b. Right? Right hand side we get a plus b. When you put x equals 1 in left hand side, we get 3. Subtract x equals 1, here 4, here minus 1. Then we get 3. A plus b is 3. Put x equals minus 1. Then again, this is 0, the product will be 0. We get b minus a here. Equals, when you put x equals minus 1, we get there minus 5 people. Number 2. Then write in this one 5 marks given. Take in this 10 marks, this also 10 marks. By solving this 1 and 2, 1 plus 2 gives b minus 1, and thereby we get a as 4 by solving these two equations. Right? So it is not compulsory to use this method, right? Right. So then for each 5 marks here, 5 marks. Then remainder you can write substituting for A and B. Therefore, the remainder. Ax plus b, no, A is 4. 4x minus 1 is the remainder. Right. Now, next one. Without using the remainder theorem directly and using only the above result, so that when fx is divided by x minus 1 and x plus 1, the remainders are 3 and minus 5 respectively. Right. Now, this one I am writing again, substituting for this ax plus b, the remainder we got the answer for x minus 1. Right. Okay. Now, I'm going to arrange the right hand side like this. Asking to find the remainder when this is divided by x minus 1. People, now this 4x minus 1 I am going to write like this. 4x minus 4 plus 3. Am I correct? This 4x minus 1 I write 4x minus 4 plus 3 because minus 4 plus 3 is minus 1. And this thing. Now, from this term, this 4 you can take out, x minus 1 comes plus 3. So we have x minus 1, x plus 1, 5x. Now, this x minus 1 and this is common, take that out. Take x minus 1 out. Then what do you get there? X plus 1 here, 5x plus 4 plus 3. Left hand side we have this. Now what can say here? When this is divided by, this is your divisor. Then this is the quotient. Then what should be this? This is the remainder. Then of course, using this result, we could show when this is divided by, right? This x minus 1, the remainder is 3. Correct, no? Okay. All right. Then for this one, write in this way, using this we get 5 marks. And getting this answer and writing, therefore the remainder is 3, another 5 marks coming. Right? Similarly, people, again this 4x minus 1, we write how to say the second answer. Okay. This 4x minus 1, I write like this. 4x plus 4 minus 5. Then take 4 out. Then x plus 1 forming. Leaving this minus 5 aside. As here, this place will be x plus 1 now. Once you take this x plus 1 from here and here out, this place now x plus 1. Then something coming within bracket. And this minus 5 coming here. Leading our answer what? When that divided by x plus 1, remainder is that minus 5. I think you can take that part. Okay. So, that part also 10 marks coming. Write in this display 5 marks and take in the last answer 5 marks. So, therefore, I'm not going to do that now. That part is over. Right. Next one, the part B. Right, people, today we supposed to do only the pure part, other only one part we have. The applied part we do in the next discussion now. Right. Okay, now next one, the straight line part. Yeah. What is that? Find the equations of the angle bisectors between the lines ax plus by plus equals 0 and lx plus my plus n equals 0. Right. You know how to take this. And you know this theory also we did in straight lines. This way two lines given. Lx plus my plus n equals 0 here. This is ax plus by plus equals 0. This is one angle bisector. This is other angle bisector. Can remember the theory part? How did you obtain this one? Take on any bisector a point P with coordinates x0 and y0. Draw perpendiculars from there to these two lines. Right? Then let this be M, perpendicular here M. You know these two angles are equal because this is the bisector. Therefore, these two angles are equal. Here 90, here 90. This side is common. Therefore, these two triangles are congruent triangles. Therefore, this length and this length being equal. By equating that to lengths only, we obtain the relationship between x0, y0. Okay? You can now write Pm is equal to Pn. How to write this Pm? By using the straight line theory. X0, y0, we substitute here and here. And then we put modulus. Lx0 plus my0 plus n modulus divided by what? L squared plus m squared root. Similarly, this length we take substituting for x and y, x0, y0, right? Modulus ax0 plus by0 plus b root a square plus b square. Then we can eliminate modulus from both sides, and to one side we had put plus or minus, right? Then finally this x0, y0 we write using xy, okay? Then we get what? Lx plus my plus n divided by the square root of L square plus m square plus or minus ax plus by plus c divided by 6. Okay. Then by plus sign, we get, when you take plus sign and simplify this, we get one equation. Minus sign and simplify, we get the other equation. That is how we take the two equations of the bisectors between these two lines. Right. That is okay. Now the next part. Two sides of a square lie on the angle bisectors between the lines 2x plus 3y minus 2 equals 0 and 3x plus 2y plus 1 equals 0. Right. If one vertex of the square is 1, 4, show that there are two squares. Find the equations of this sides of the square. Also find the area of a square. Right. The two lines given now, people, 2x plus 3y minus 2. I'll take the two lines like this. One line is this. The other line is this. First line, 2x plus 3y minus 2 equals 0. The other one is 3x plus 2y plus 1 equals 0. Between these two lines, there are two bisectors. One bisector is this. The other bisector is this. People, when we consider the two bisectors between two lines like this, that two lines become perpendicular to each other. This angle is 90. Okay, take any two lines and draw their angle bisectors. The angle between that two angle bisectors is always 90. Now this question says two adjacent sides of a square lie on these two bisectors. That's what it says. Then people, first of all, will find the equation of this bisector and this bisector. After that, we'll draw another diagram showing these two sides lie on the adjacent sides of a square as given in the question. Okay. Then to find these two equations, now you can use this result. Then what is that result? Directly follow this now. What? One equation divided by the square root of x coefficient squared, y coefficient squared, plus or minus other equation 3x plus 2y plus 1 divided by 3 squared plus 2 squared 2. These two you can cancel down. Okay. When you take people plus sign and minus sign separately and solving this, the two equations we get, I am going to write. One equation come in x minus y plus 3 equals 0. The other one come in 5x 5x plus 5y minus 1 equals 0. This way, we get the two equations of the bisectors. Then really, the marks we get here, write in this 10 marks, take in people this final answer, 10 marks in the theory part, and using that, write in this 10 marks, and finally, getting these two equations of the bisectors, each 10. Now we get marks. Right. Now, the two equations, this and this, are the equations of this and this. Okay. Then I am going to go new diagram. Yeah, now I take this line as this one. The other one is this. Line is 5x plus 5y minus 1 equals 0. This one is 6 minus y plus 3 equals 0. Now, what is the question given? Find the equations of the angle bisectors. That's okay. No, two sides of a square lie on the angle bisectors between the lines this and this. One vertex of the square is 1, 4. One vertex of the square is 1, 4. Right. People, now this point, if I take as A, the coordinates of this point you can find how? Solving this equation and this equation simultaneously, you can find this point A. Then solving this and this, x minus y plus 3 equals 0 and 5x plus 5y minus 1 equals 0. You know how to solve these two equations. I told two methods. One is by equating coefficients of x or y and subtracting or adding the two equations, finding. The other method also I told, no? Right? So anyhow, people, using one of these methods, you can find x and y. I write the x value here, it is minus 7 by 5 coming, y value 32 by 5. This point, minus 7 by 5, 32 by 5. Okay. Our next one given, yes, one vertex lies on one vertex is at 1, 4. That vertex should be, people, on this line or this line. The vertex is 1, 4. People, you have to see if this 1, 4 line lies on this line or this line, definitely this 1, 4 coordinate should satisfy that equation. People, this is the equation. Why? 1, 4 satisfies this. Put x equals 1, y equals 4, 1 minus 4 minus 3, minus 3 plus 3, 0. So therefore 1, 4 point should be this. This is one vertex. 1, 4. Now asking, these two sides are the adjacent sides of a square. One vertex is this. Asking because there are two what? There are two squares. Possible, people, here. I take somewhere here 1, 4. Then one square is this. 1, 4 is one vertex, this side and this side, adjacent side. And the other one thing is this way. Right. This. Correct? For this square, one vertex is 1, 4. One side is this, other side is this. Therefore, there are two squares. Right. These four sides are equal. Okay. Now we have to find what? Equation of this side, and this side. Three equations we have to find. Right. How to find the equations? Right. People find in this point A, given 10 marks. This way, right? X coordinate 5, y coordinate 5, 10 marks. Okay. Equation, I mark this one, people. This point as D. This is C. This side we can write. The equation of this side CD we can write. There are three equations we have to find. This one, and this one. This one you can very easily find. How? You know, since this is a square, this side and this side are parallel. Then the gradient of this line and gradient of this line equal. Gradient of this line can be found by using the equation of x. How to find gradient? Subject y. When you subject y, take this and this right hand side, minus 5x plus 1 divided by the 5. This way. This cancel down, then expression is minus 1. That expression is the gradient. So therefore, the gradient of this is minus 1. Therefore, what is the equation of this CD? Take this 1 and 4 as x naught, y naught. Then what is the equation of CD? Right? Equation of CD. Y minus y naught. Y naught is this 4. Equals gradient is minus 1, no? It's minus 1. Simplifying this, you get the equation of CD as y plus x minus 5 equals 0. For this 10 marks coming. And the two sides we have, this side and this side. Let's see how to find that. Equation. Right. That equations we can find very easily like this. Okay. Now I'm going to find this AD length. This AD length, we need to find the area also. Finally, asking the area of the piano. AD squared, how to write? Difference of x coordinates perfect squared. 1 minus 7/5 perfect squared. Right? Difference of y coordinates perfect squared. 4 minus 32 divided by 5 perfect square. When you simplify this and take the root, people, this AD comes as 12 root 2 divided by 5. The simplification part is up to you. If be able to simplify this kind of thing. Right? Now, right. We can assume, you know, people, this line and this line are parallel. Opposite sides of the square are parallel, no? You know, this equation x minus y plus 3 equals 0. You know, when two lines are parallel in their equations, the xy terms are the same, no? We told that. Then I can write this equation, right? This equation, if I take this one as point V, equation of VC we can write like this. Equation of VC, we can write how, people? Since this and VC are parallel, x minus y plus c equals 0. In this way, we can write what? The equation of VC. This c is unknown. We have to find this c. Right. Here, finding this AD, we get for this one 10 marks given, this one 10 marks given, 20 marks altogether given. Now we need to find this c. If you know this c, putting that there, we can find the equation of VC. To find that c, this is what I do. You know, the length this is also 12 root 2 divided by 5. But this length from here to here, perpendicular distance, you can think as from this 1,4 point to this line, the perpendicular distance is this. You know, people, how to find the perpendicular distance from a point to a given line. This coordinates xy, we substitute for this x and y and take modulus. Divide by what? Square root of x coefficient square plus y coefficient square. That is how we find the perpendicular distance from a point to a given line. We'll use that theory. Then 1 and 4 we have to put here and here. For that, DC is also 12 root 2 divided by 5. DC line, DC length now we are going to find. Put this 1 and 4 for x and y. 1 minus 4 plus 3 modulus divided by 1 square plus minus 1 square root. This is equal to this 12 root 2 by 5. Right. Now we can simplify. Here what do you get? 3 minus 3 modulus. This is root 2. Here 12 root 2 divided by 5. Use the cross multiplication like this. What do you get there? 3 minus 3 modulus. Right. Here root 2 into 2 is here 2, no? 24 divided by 5. Then remove the modulus, put to the right hand side plus or minus 50. There, then the split right hand side 50. There are two answers coming for C, people. Why do we get these two answers? People, satisfying this all conditions so far we have used. There is another line on the other side that is C. See here, all the properties here we use are equally true for this line as well. The distance from this point to this line is also 12 root 2 by 5. That is why we get two answers for C. Then by that two answers, we get, people, the value of C. Then one C will give this equation. Other C, when you put here, we get the other equation. That is how we find the two sides, right? Then simplifying this, we get the two answers for C people. One is we get 39 by 5. Other one we get minus 9 by 5. Okay. And then we get here for what? For what? This one. This one, 10 marks come in. And here put in plus or minus this 10 mark. And for this answer 5, this answer 5. Then substituting C, this answer, we get one equation. Substituting other C, where here we get the other equation. Then you can write therefore the equations, required equations. Therefore, required equation. What do you get? X minus y plus c, 39 by 5 equals 0. The other one, x minus y minus 9 by 5 equals 0. That you get for each 10 marks. Finally, asking people the area of a square. Area means people, this length and width, no. The side we know, 12 root 2 by 5, no. Then we have to multiply that itself. Then the area you can write the last answer. The last answer is area. Therefore, the area of a square. But 12 root 2 divided by 5 perfect square. This way we can complete that question too. Okay.